total silence. They were supposed to all say something, and everybody chickened out. Okay, what's up? 4 minutes. Class start 4 minutes ago. Go, hurry. Okay, for everyone that is not here, good luck on competing. Okay, we are still in 10.2. So, the shape that we just had on question 3 looked like a circle with how many tangent lines? We had two. We had two tangent lines. One right about here, and one, Rodelia. Yeah? And one right about there. Sit down, both of you. Okay, we have two radius going out and going out here. Let's call these R and R for radius. And we have our center. So, Sylvia, my tangent line in blue and my radius make what? Yes, a right angle. So a right angle here and a right angle here. Right there. And this is called, what is this angle right here called? What is this angle right here called? What was it? So you mean theta? Yeah, okay, we call that the central angle. That was from 10.1. That is your central angle right there. So we meet at this point out in space. And we have a theorem to go with that. So this is theorem 10.2. And this is called the segment tangent to a circle theorem. Has a long name. This states that if we have, how many tangent lines do we have? Two, yes. So if two tangent lines of a circle meet at some point, say at some endpoint, So in this case, that endpoint is going to be right there. So that is A. Then the segments are congruent. So the segments that they're talking about here, let's label some. This point will be B, this point will be C. So they're saying that I don't like that color. AB is congruent to BC. What dots? This is C. I know, I don't like the color either. This is B. This point over here is A. There we go. Is that better? Okay. So AB is congruent to BC. Nope. Not BC. It should be AC. Sorry, guys. To AC. So if tangent lines AB and AC meet at point A, then AB is congruent to AC. And these two are two tangent lines of what circle, if I label my middle P? Circle P. Any questions about the theorem as you're writing it down? Evan, why do you have them all?
What? Yes.
Give him all of them? Okay, I'm going to scroll down a tiny bit so I can write our next problem. I'm just going to sketch it. Okay, thumbs up when you're done writing. Yep. Okay. I'm going to scroll down a little bit. Okay, we're going to talk a space problem because you guys like to talk about space a little bit. We're going to draw the Earth first. Earth is roughly what shape?
Sphere.
Yes, and if I put it on a 2D plane, is a circle, right? Yes. Okay, so this is Earth. And if I were to text somebody right now, it has to hit what on this island before going up into space? Yes. So I'm going to draw 2 little satellites on the side of Earth. One right here. And one roughly right here. Now, this signal has to hit what out into space? Yeah, a satellite. Okay, we're going to see if I draw a line from where we're at now all the way up to the satellite. Actually, let's choose a different color. From here. Say I'm in Alaska. Okay. It has to go up to the satellite and go back down to text if I was texting someone on the other side of the world. So let's say New York, even though they're not exactly that far apart. These 2 lines right now are tangent to this circle. I want you to find how long it would take from getting where I'm at up to the satellite and back down, given that the speed of radio waves travel at a speed of 300,000 kilometers per second. I didn't give you all the information that you need to solve this. What else do you need to solve this problem? What distance? Okay, so that's what you're trying to find. You're trying to find this distance and this distance. Yep. So given what's above in our theorem, what did I not give you? Okay, so you want to know the radius? Yes, no? Okay. Does anyone already know the Earth's radius? No? Okay, Earth's radius is 371 kilometers. That is the Earth's radius. You need one more thing. And I'm just going to tell you what it is. It's going to help you solve. The distance from this satellite to just touching Earth, right there, that distance right there, is 35,786 kilometers. You're going to have to solve for the x's in this. So first, find the distance from, what do you want to call this? From a ground station. So that's these little guys. These are ground stations. So what is sending the signal to the satellite? and then I want you to find the time, find the time it takes for the radio waves to reach the other ground station. Okay, do you guys want to do this one on your own? On the boards. Oh, I not like this. Okay, we'll do this one on the boards. Yeah. Jack's on group 1. 8 is in group 4. 9s will be on the doors. And 10s will also be on the doors. Oh, I forgot. Maybe go on here. Who's a 9? Oh, you're down here.
What?
Okay. Show your cards. Find groups. Oh, okay. Go find your partners. Rodelli, what are you?
8 again.
8. Vincent. Rodelia. Klein, what card you got? Oh, 8. Okay.
Why didn't you tell? Wow, you don't want to be in my group, huh? You didn't even want to show.
The cousins.
Us three and Sevilla are all cousins.
I didn't know that.
Any someone in here are cousins.
Yeah, pretty much it's the whole school. We're all.
You guys want to be in a group together?
No.
Okay. Let me pause this. Hey, do we want to put this one in our notes?
Yeah.
Okay.
Should be cool.
Oh, thank you. Okay, what additional lines did we draw to help us figure out this problem? Yep. So this one, and what else? Roughly that. Yep. Okay, where are my 90-degree angles? Okay, where each ground station is. Right there and right there. So we have how many right triangles? 2. Okay. We know, what is the length of this dotted orange line? Yep, so this is also a radius. What's this length right here? Yep, also the same there. So we're looking at one of these triangles. We only need one. Why do we only need one? I need a little more than that. The triangles are the same because this length is congruent to that length. By what theorem? Yes, the one we just did. The 10.2. So if you look above, it's going to happen every time when we have 2 tangent lines meeting at one point. So we're only looking at one triangle right now. This one right here. We have a 90-degree angle. We have, what's my length of my hypotenuse right now? Yeah, and Liam, how did you get that? Yes. So we took the blue distance, so how far away the satellite is from Earth. So the blue, which was 53,786, and we added that dotted distance, which was how much, Rodelia? How much was this dotted distance?
I don't know. How did this?
You know what it is.
I do.
Yeah, you do.
Oh, it's supposed to be 6,000.
Yes.
Oh,
Why is that?
71.
Why?
Because yeah, it's the same as the radius.
Thank you, Klein.
Sorry.
It's okay. Okay, we're trying to find. Well, we know this side as well. This side over here. So if I know two sides of a triangle and I'm trying to find the third, what can I do? Anybody? Yes, Pythagorean theorem. So what was my hypotenuse again, Liam? 157 squared plus 6,371 squared plus x squared. What do we get as x squared once we square it and subtract it one from the other? Yeah. Yes, I can. Okay. Better or worse? Okay. X squared equaled what? Okay, we'll back it up a step. What is 42,157 squared? 177. I'm just coming from the board in the back. 6. No, 2 6. 2 6 4 9. Yeah, equals this gigantic number plus x squared. How do you get x squared all by itself? Yes, and then square root, Kevin. Yes. So this should have been 17366230008. Then we square root both sides, and we're left with how much is x? What did you all get? 41,672.81. We'll call it that. What's my label? Yeah. Am I done? No, because I only went from the ground station to the satellite, right? And I need to go back to satellite to wherever the message is going. So what do I have to do to this number? Yep, so multiply it by 2, and we should have gotten 833, oh no, 83,346.61796, roughly. That's the number, yeah. Because I want to go from this satellite, no, this ground station, up to the satellite and back down. So we know x, but I also need my other x. Yeah? Okay, now that's the answer to number 1. Okay, how do I get the answer to number 2? What do I have to do? By what? Divide by speed of the wavelengths. And this is kilometers per second. And this is kilometers. So what am I left with? Yep, and what is my label? Yep, seconds. So it takes about 0.28 seconds for a message to go up into space and come back down, even if it's on the other side of the world. I know, right? That was this number. Yeah, because you have to multiply by 2. Because that's to take all the way up and all the way back down. Yep. Cool. I'll go back. This is your homework for tonight. Homework. Oh no, I didn't write the homework down. I need a notebook. We're going to write it down now. And then we'll see if we're going to continue on or not. What was that? Oh my gosh. Okay, just add it to your homework from yesterday. And let's see. So on homework 10.2, page 437. And let's do, ooh, that one looks weird. You did 5 and 6, right? Yeah. Okay, do 9, 10, 16, 17, 8, okay. Do 16 through 20. Okay, that's your homework. Do you want homework time or do you want to do a cool math problem? Whatever. Well, you have 15 more minutes. Okay. We're going to look at something cool in math. Okay, how would you all pronounce this name? Okay. Apollymus? So
We have to write this.
you don't have to, but I think it's cool. Problems of Apollymus. So this was a very old Greek guy who talked a lot about circles and tangents of circles. What's up? You can listen. You can write down something. I want you to draw 2 circles. Any shape, any size. I mean, it's going to be a circle. So I'm going to draw 2 circles like this. I want you to draw as many tangent lines as you can that are tangent to both of these circles, but like don't go across the circle because it's a tangent line. I want you to draw as many tangent lines as you can that touch both of these circles. So you need to draw a tangent line. I'm going to draw you all one. So it can only touch how many points in a circle? In one circle, it should only touch 1 in each circle, right? Okay. The lines can cross. Like right there, it touches at this point right there and that point right there. So it's 1 point on each one. And it makes a 90-degree angle with the radius. Do a rough sketch about what these 4 lines would look like. Both of these circles. How many did you come up with? You didn't even write the steps of the problem. Oh, boy. Okay. Okay, so if you finished roughly, how many did we come up with? 4. Okay, there should be 4. Yes. No, they can't ever be possible more than 4. It's always gonna be 4. Okay, mine is bad because I can't change it. So, oh. Okay, I'm just gonna draw the diagonal ones. So that's 1, 2, roughly those 2 right there. And then 1 diagonally across. My sketch isn't the best. Okay, that's the start of his problem. So it's always 4. Yeah? Okay, draw 2 that kind of look like a Venn diagram. This one and this one. Yep, two overlapping. And then when I do two, one is inside the other. There's more. How many tangent lines can you draw that are tangent to both of these circles? Okay, where's one? How many tangent lines? Okay, this is a pair of circles, this is a pair of circles. Liam, how many for the first pair? Okay, how many on this one? 0 tangent lines. I need a brighter color. What about the second pair? 2. So 2 tangent lines. So it's above and below. I could have drawn them better by hand. Okay. We're not done. That's just the start of his problems. Now, what? We're gonna keep doing this. Okay, draw 3 circles. No, not touching. 3 circles. Do them of different shapes. You're gonna have to draw this many times. So I'm gonna draw the same thing again and again and again. Okay. Those are my 2 pairs. How many circles? 2? Okay. You don't even know what I'm gonna say. We have 3 circles. Yes, this is a pair. This is a triple. 3 circles, right? I want you to draw a circle that touches all of these. That is tangent to all of these circles. Yes, I'll give you the first one. You need to draw a circle that is tangent to all of these circles. So a circle that only touches at one point of all of these circles. When? What? That's one of them. Yeah, so this is one way. Okay, that's the second way. Vincent got a second way. It should be. Mine isn't that good. So this is a second way. How many ways can you find? I mean, you probably can get it. Yeah. I think it's gonna be a little difficult. How many ways are there to draw one circle that is tangent to all of these circles? Okay, that's 2 so far. There's more. I promise you. Oh, there's more. There's more. Yeah, I wouldn't draw. That's gonna be very difficult. Yeah. Yeah. It has to be a circle. Like, you have to draw a circle that is tangent to these 3 circles. No, that would be a line of tangency, but I want a circle of tangency.
Yeah, I got it, genius. Never mind.
Prime, do you have another way? Elijah, yeah, what's up? Okay, which one do you want to put inside? Big one? Okay, big one inside. So if I understand what Elijah wants to do, he wants to do something like that. Yeah? Okay, that's a third way. I bet there's more. There is more. 6. Edit. Paste. Okay, Vincent, come up and draw you away. Yeah, I did. Come up and draw your way. Yeah, your way. Okay, so on here. Or you can draw it on there.
Oh shoot. How do I draw this? Yo, how do I draw this? Yeah, I just draw this.
Okay, if you think you know a different way, go draw it up on the board.
Yo, sweet. How does this work? Sweet. How does
Yeah.
this work?
No, it doesn't. But draw it with like an X marker and I'll sketch it. Who else has another way? Go, draw up on the board. Okay. Liam, go draw another way up on the board. Riley got another way. Yeah, go draw up on the board. Okay, I'm gonna have to scooch down. Elijah, do you have another way? I'll give you a hint. There's 8 ways to draw this. There are 8 different ways. I don't know. Go up and sketch it. Liam drew 1 circle around. Okay, Liam drew his like this. Yeah. Okay, Ronaldo did this one. There are 2 more ways. Oh, that was an ugly circle. That's my phone. It's a circle. It's supposed to be a circle. Okay, we're almost done. There's only 2 more. We're missing 2 ways.
Circle the 2 on the. Oh wait, never mind. Circle the top one on the left. Okay, sorry.
Top one.
Like go around both of them and then do the inside of the. Oh, that's a one. That's cool. Oh, wait, what?
What other way?
Like outside, here, and then inside. So just circle those 2.
Okay. Vincent, last way is yours. Up on the board. Yup. We have 1 more way.
Oh, I see it.
Yeah. Great. Boom. Like that. Okay,